Welcome to solverfy.
Hello everyone, today we're doing chapter 19, problem 42, and this problem asks us to determine which of these two molecules, pyruvic acid or acetoacetic acid, has the lower pKa, therefore being the strongest acid, and explain your choice. Well, remember, the stronger the acid, the lower the pKa, and the stronger the acid, the more stable its conjugate base. So the more stable the conjugate base means that we can have three ways that we can stabilize a conjugate base. Number one, putting a negative charge onto an electronegative atom, typically being oxygen, which both of these does. Number two, resonance stabilization of that negative charge, which both of these can go through. Both of them will have two resonance stabilization effects, two resonance structures which are indicative of resonance stabilization. And third, the inductive stabilization, the inductive pull of electron density away from these negatively charged oxygens onto some sort of electronegative group to inductively stabilize your conjugate base. So both of these we have ketones that are adjacent to our carboxylic acid, which can inductively stabilize our conjugate base. But now the only difference is that we have this one carbon linker in acetoacetic acid, while in pyruvic acid, this carbon is directly adjacent and bound to the carboxylic acid carbon. So in essence, we can say that this inductive stabilization effect felt by this ketone is in closer proximity for pyruvic acid than in acetoacetic acid. So therefore, the inductive stabilization effect for pyruvic acid will be greater than the inductive stabilization effect felt for acetoacetic acid because of the increased space in between the negative charge and the electron withdrawing group here. So because of that, pyruvic acid conjugate base will be more stabilized. Therefore, the acid will be more acidic and have a lower pKa value compared to acetoacetic acid, which will be less acidic and therefore have a higher pKa value.